Now, number 3 and 4 introduces us to very small numbers. Number 1 and 2, we're using standard form to represent very big numbers. Let's see how it works the other way. So on question 3a, the number I'm going to use in my standard form way of writing this is going to be 2. It's the only digit in the question. Now, what power of 10 do I need to make this actually equal 0.002? Well, the decimal point has had to be moved to get it after the 2. So it had to be moved once, twice, 3 times. So my power is going to be 3, but it's going to be negative 3 because it has moved the other way. Okay, and if you think about 10 to the power of negative 3, if you remember the earlier pages of this pack, 10 to the power of negative 3 means 1 over 1,000. It doesn't mean any negative number, it just means 1,000th. And that's what we've got here. We've got 2 lots of 1,000th, so we've got 2 thousandths, 2 in the thousandths column. Okay, and this one, I've got 2 in the 10,000ths column. Sorry, a 5 in the 10,000ths column. So this is 5 times 10 to the power of negative 4. Or, in other words, the decimal point has had to move 4 times, but 4 times downwards. This one would be 9 times 10 to the power of negative 1, because the decimal point has had to move once downwards. 4 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, so negative 8, and so on. I'll do the rest and you can mark yourself. So I'll just go through this one actually. So this is the first one with 2 digits in. So my number is going to be 6.5. So it has to be between 1 and 10. And I've had to move the decimal point once, twice, 3 times, 4 times to get it there. So times 10 to the power of negative 4. Don't forget the times 10 bit. Loads of people make the mistake of just skipping straight to the power and putting 6.5 to the power of negative 4, for example. That would be a completely different number. You have to remember the times 10 bit for standard form. Okay, question F would be 2.2 times 10 to the power of negative 3. And so on. I'll do the rest and you can mark. Okay, there's the answers to question 3. Number 4, we need to write these numbers as ordinary numbers again, so it's doing the reverse again. Now the only difference this time round is that I know they're going to be very small numbers, so I know it's going to be 0 point something, probably some more zeros there. So this time I'm going to write my digit down. I'm going to write it over on the right hand side, so give myself some space to add some zeros to the left. So I'm going to put a 2 there. And I'm going to move the decimal point 3 times from where it is now. 1, 2, 3. That's where it's going to go. I need to add in 2 zeros here. But also I need something in the units column. I need a digit in the units column. So I'm going to put a 0 there. So 0.002 would be the answer. On part B, again, I'm going to start with 7. And I'm going to move the decimal point twice because the power is 2. So 1, 2. That's where the decimal point is going to go. I can see I need to add in a 0 here and a 0 there. So 0.07. On C, I'm going to put a 3 on the right hand side and move the decimal point 6 times. 1, 2, 3, 4, 5, 6. So I need to add in 5 zeros there and another 0 there. Little hint on these ones, little tip. On the negative power ones, the number of zeros we have to add is always equal to the number in the power. It's not always the case with the positive power ones. As you can see, for this one, I've got 6 zeros on this number here, 54 million. But my power is 7. That's because the 4 takes up one of those places of a 0. But on the negative ones, the number of zeros is always the same as the number in the power. So this one, because we include the units digit as well, this one would have 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 zeros, and then I put my number. Okay. On part E, My first 0 will be the one in the units column, so 0 point, and then I need 3 more. 1, 2, 3, because I need 4 in total, and then I need the digits 4 and 8. On part F, I'm going to have 3 zeros to lead with, so 0.00, and then 6, 7, because those are the digits in my question, and I'll do the rest and you can mark them yourself. Okay, there are the answers to question 4. We then somehow jump from question 4 to question 6. Whoops. Okay, now, this question says, write each of these numbers in standard form, but it looks like they already are in standard form. We've got a number times 10 to the power of something else. Now, what is not in standard form about these? Well, it is that multiplying number. As you can see, it breaks that rule we mentioned at the start, where this number has to be between 1 and 10. Okay, so it has to be greater than or equal to 1, but less than 10. And 72 is obviously more than 10. So here's my way of doing these. You don't have to use the same method, but there are many ways of explaining it. 72 I could change to be between 1 and 10 by moving the decimal point to there. So 7.2. Now if I think about what I've done to that, I have divided by 10. Now I can't just divide a part of a number by 10 and expect it to be the same number. I've changed it. So to account for that change, to make sure the whole number hasn't changed altogether, I need to times this part of the number by 10. Now that is already 3 tens timesing together. So if I times another 10, that would give me 10 to the power of 4. And now that number is in standard form. It's the same number as this one, but it's now in standard form. Show you again on the next one. 84 is not between 1 and 10, but 8.4 is. I've divided that by 10 to turn it into 8.4, so I need to times by another 10 here. This is already 6 tens timesing together. If I times by another one, that will be 7 tens timesing together, or 10 to the power of 7. Okay, on part C, 5 would be my digit. I've divided by 100 on this one, which is 10 times 10. So I need to times by 100, or, to explain that again, times by 10, and then by 10 again. Now this is already 2 tens timesing together. If I have a couple more, now it's going to be 10 to the power of 4. On part D, I'm going to change this number into 2.1. Again, I've divided by 100, so I need to times by 100 over here, or 10 times 10. So that's 2 more 10s I'm going to add to this power. That's going to be 2.1 times 10 to the power of 6. Let's see if I can find a different one. Yeah, so part E, this number is not between 1 and 10. If I change it to 8 though, it is, and I've times by 10. So this time I need to divide this by 10. Now, I've got 7 tens all timesing together there. If I divide by 10, one of those 10s will cancel out with this one I'm dividing by, and I will now only have 6. So this is now 8 times 10 to the power of 6. Okay, so this one I'm going to times by 10, turn it into 4.6. So I need to divide this by 10, and that will become 10 to the power of 4. Okay, on part G, I need to times by 100, which would give me 6, and I need to divide this by 100, which is 10 times 10 by the way. So I would cancel off 2 of these 8, and that would give me 10 to the power of 6. So it's about doing something to the left-hand side, to the multiplier, and undoing it with the other side. So this would be timesing by 1,000, which is 10 times 10 times 10. This would be dividing by 1,000, so knocking off 3 of those powers, reducing that power by 3, which would make it 9. Here I'm going to be dividing by 1,000, so I need to times by 1,000 and therefore add 3 to this power, so that would give me 17. Here I need to divide by 10, which gives me 2.4, and I need to times this by 10. Now this is where it gets a little bit tricky. When you've got a negative here, just think that this is going to increase the power by 1. When I increase negative 5 by 1, I get negative 4. So it seems like it's gone down, but it's not. If you think about it, negative 4 is 1 more than negative 5. Here I need to times by 10 again, so I'm going to divide this bit by 10. And so I'm going to decrease this number by 1. So it's now going to be 10 to the power of negative 11. And the final one I need to times by 1,000 to get 5.5 as my multiplier. And I need to divide this by 1,000. So I'm going to decrease its power by 3. It's already a negative 2. If I decrease negative 2 by 3, it's going to give me negative 5.